All right. So it should come as no surprise that natural language processing models such as ChatGPT will undoubtedly make their way into the field of programming. And most likely, you've seen people post on LinkedIn where they use ChatGPT to write code using some uh, common-ish library that people have extensively used, whether it be Pandas or NumPy. I'm sure everyone at this point has seen some kind of demonstration for it, writing some kind of code to visualize whatever it is you're aiming to see. But what I was more interested in is how well ChatGPT can perform in situations that are rather unique. And unique in the sense that only a very small sort of niche community, such as the image.tiffsave forums, would be able to provide a specific use case scenario, one that, would require a little bit of creative thinking or the use of specialized libraries. And that's where I was interested in seeing how would ChatGPT perform in a situation like this. So the particular challenge I had in mind came from a forum post. Uh, I guess my forum post. I made a comment about um, being able to convert MRXs files into something more open source, such as the OMEtiff standard. Now, MRXs, if I recall correctly, was a proprietary image format from Hamamatsu-based slide scanners. And OpenSlide kind of supports native .mrxs reading. From what I've seen, QPath through the OpenSlide builder does a reasonable job loading in these files without any issue. But a few people um, have posted on the forum that, hey, I'm trying to basically figure out how I can load in MRX's files and convert them into something a little bit easier to use. So, here one forum user mentioned, especially because the MRX's format is not that nice to handle, I'm sure you'll find countless GitHub issues open up on a variety of, forum posts. Um, I can find an example. Yeah. So, as the name would suggest, not a lot of people are happy with using MRX's format, and I'm sure they would much prefer something like TIFF or OMEtiff, which allows you to specify a lot of different attributes of the image's metadata. So, I was recommended this amazing package called pyvips, and pyvips, being led in development by John Kupet, is this package that acts as an API for libvips. Now, libvips, this is going to be a tongue twister, but libvips um, does a phenomenal job in being able to load very large images or process very large images with limited RAM footprints or limited memory footprints. And the reason being is that it essentially builds this sort of pipeline where it can start processing not the entire image at once, but, strips or even tiles of that image one at a time. So that way you can essentially load in a 60, or you can process a 63 gigabyte file, but only load in, transiently a few gigabytes at a time. So with the gracious help of John Cupid, I've been able to basically modify this script that he kindly shared with me to convert a MRXs file into an OMEtiff. So I'm going to demonstrate right now what happens when I run this script using a example image from the OpenSlide test database. There's a couple of images here. I don't think those fully encompass the heterogeneity in MRXs files that one can come across, particularly in terms of variations in bit depth, tile size, fluorescent versus bright field, choice of compression scheme, and a variety of other things that can vary in the MirX system or MirX format. So on that note, let's see how well it does converting CMU-3.mrxs into an OMEtiff. So I'll hit save. Another thing to note is the installation I have for pyvips is slightly convoluted. I actually downloaded the libvips binaries by themselves and included them into the path variable just because I didn't want to like include it globally and muck around with DLL hell, or basically DLL conflicts. So on that note, let's run the script, see what we get. While that runs, I will quickly pull up the CMU-3.mrxs file. Now, one thing to note is CMU-3.mrxs is only 649 megabytes, so a little under half a megabyte, but it is so heavily compressed that the uncompressed size is almost 35 gigabytes. And this is a whole slide image of multiple tissue sections measuring, several tens of thousands of micrometer in length and a resolution of 0.23 microns per pixel. So it is a fairly high resolution image. And while QPath doesn't have an issue loading in this particular MRXS file, I'm interested in seeing if anyone else can provide an example of an MRXS file that they're having trouble with loading into QPath. Because in the latter part of this demonstration, I essentially asked ChatGPT to construct a converter from MRXS to OMEtiff, and ultimately I want to see how well this does in comparison to the gold standard, being, the segment of code provided by John Cupid, developer of pyvips. So if we take a look at the memory footprint itself, I can actually sort it by here. A little under 2 gigabytes is being used by Python. QPath is also loading in 2 gigabytes worth of imaging information. That's just because I have this original MRXS file opened. And yeah. Given that I'm not entirely sure how long this will take, I will I will pause the recording here and resume. Or no, I'll keep the recording constant and I'll just crop out the portions of the video that are just me waiting for this thing to run. All right, so the code has finished running. The code written by an actual, human being and not ChatGPT. And we can see that it, in fact, has been able to load into QPath without any issue. So this is the original MRXS file. This is the OMEtiff. Both of them are 35 gigabytes in size. Dimensions, pixel values, all of it remains the same. The pyramiding might be slightly different. So here the highest layer is 512. This one over here is, it's also 512. So not really any change in terms of how it was pyramided. For the most part, no latency, no noticeable JPEG 2000 compression artifacts, or whatever compression scheme was used. We now have an OMEtiff, which not only we can load into QPath, but other imaging modalities, or image analysis platforms. So now let's take a look at ChatGPT's version of it. The actual code I had was from querying it with this question: write a program in Python that will convert an MRXS image file into the OMEtiff using the pyvips package. There are other packages that do support writing out of OMEtiff, such as tifffile, I think. I just wanted to use a package which I had some familiarity with in order for me to debug things if things weren't going as expected. So let's take a look and see what happens if we run it as is. Now, if you actually notice, all it says for libraries that are loaded are just import pyvips. If we were to comment this portion of the code out, so this portion of my manually written stuff, and we're just to load pyvips, might actually need to restart this. You can see it gives me an error, missing a dynamic link library or DLL. I had a semi-custom installation of pyvips, or way to import the pyvips library, because I had downloaded the libvips binary files themselves and manually put them into the path variable. So that's one thing that ChatGPT kind of struggles with, is context. The method of installation of pyvips is not just like loading in any package from conda or pip. It does have external dependencies like the libvips binaries, at least in this particular installation that I wanted to get working. So that's one thing to note. It will most likely never really be a plug-and-play situation with ChatGPT and programming. You do need to have like some baseline understanding of how the package works and what other things need to be loaded in. Other thing to note is I just commented out this portion of the code. The actual conversion is kind of wrapped together as this little function called mrxs to tiff, where it passes a bunch of additional arguments like enabling pyramids, bigtiff formats, tiling, tile parameters. Sample format's going to be a little bit interesting. It said uint16, however, this particular image is uint8. So I'm curious to see what actually happens if we try and run it as is. So on that note, let us run it and maybe call it something a little bit different, like ChatGPT, just to help differentiate from the previous run. TiffSave does not support optional arguments sample format. Interesting. So my understanding is this actually is in fact a bug with, or a bug induced by how ChatGPT wrote this. We cannot pass this argument, so let's comment this out and run. So given that the previous conversion took about 5 minutes or so, I will end the recording here and pick up once the conversion has completed. So the script's finished running, and now we basically have a ChatGPT generated version of our converted mrxs file into OMEtiff. But even though it looks the same and you can zoom in, no compression artifacts, nothing abnormal compared to the original mrxs file, one thing that stands out is white space. So if you look at the ChatGPT version, you'll see that there's a little bit of padding almost, or unnecessary white space present on the OMEtiff that was not originally present on the mrxs file. Now, to be fair, I had the same issue when I was running the script recommended by John Cupid, which is why I essentially asked a question, about all of the white space that's present. And his response was to add this argument, autocrop to true. Now, to be fair, in the initial prompt that I had fed ChatGPT, I made no mention that I wanted to remove this white space, but also I didn't have the a priori knowledge that white space would be preserved during conversion of image format, or rather unnecessary white space. So in its defense, it was doing what it was prompted to, but sometimes you might want, what's the word I'm looking for? Things that are not explicitly said to be a part of your program. including efficient trimming of unnecessary or useless data, which in this case is the white space. Now, with John Cupid's script, or rather modifications to the initial script he recommended to me, it works. It works excellently, and in fact, he's actually updated the documentation on libvips as well. But here's the thing. ChatGPT, at least to my understanding, is limited to data from 2021 and before, and that also means data that's been digitized and accessible to, well, the internet, as that's where I'm presuming it got the data from. Now, on the opposite end, you have people like John Cupid, who not only is a developer of libvips, but is an extremely intelligent individual with years of computational history predating what ChatGPT was trained on, because there are times where presumably throughout the course of his life he had learned from something that wasn't present online, and also knowledge that he may have and reflected in new versions of libvips that post-date 2021. A good example is any edits to this page. If an edit is made, would ChatGPT be made aware of this edit if prompted again? Not necessarily, at least to my understanding, because as I previously mentioned, this data is limited to 2021 data and before. So yeah, it can't update its knowledge base to current knowledge. So the moral of the story, and I'll pull up the ChatGPT version of the script, is that yes, ChatGPT can write code. It can write code to convert certain files, for example, but that assumes you actually have some one posting a library on the internet that is capable to achieve this. Now, the reason I didn't title this video like something clickbaity as though, or like a ChatGPT reverse engineers a proprietary image format, is because it didn't, and I don't want to be misleading to people watching this video. It realistically was the work of John Cupid or any developer who's making a image conversion library that actually made this conversion possible. ChatGPT can look through existing documentation and using some context can convert an image file if I say point it to a specific library. But let's say I create a new chat and I ask it to create a script to convert MRXS to OMEtiff. Let's see what happens. Oh, it's seemingly doing a pretty good job. I'm not going to rerun this script simply in the interest of time and not this having to be a very long video. But as you can see, from the first few lines of code, it is importing libraries. It is importing libraries that have ways to actually convert the script, convert these image formats into a different type. So when I write something like create a script to convert MRXs to OMEtiff, it's relying on existing human knowledge and existing libraries developed by human beings to perform this conversion. And to keep things short, I believe the utility of ChatGPT, at least in the field of digital image processing, is not so much to create novel libraries or novel functions or novel ways to accomplish any task in the field of digital pathology, but rather as a database to reference certain libraries and combine them together in certain functions to achieve a common task. That being said, it might not perform as well as a human expert in the subject area, as evident by the fact that we see, this white space padding present. So on that note, yeah, I'll end the recording now. I want to give a big thanks to John Cupid's work. libvips is an amazing library for not only image processing, but memory efficient image processing. And yeah, thanks for your time.